Hi, I'm Usman, and today we're gonna start. We left the lecture last time on the topics which was numbers, right? So we're gonna hopefully continue from there. I hope that you all are doing great today. All right. So without wasting much of our time, let's just begin with this. Okay. So now what we studied last time, I'm just gonna give you a brief overview. We studied different types of numbers. All right, we studied the different types of numbers, right? We studied how what are prime numbers, what are rational numbers, what are irrational numbers, right? And now we also did study about multiples. What are multiples? All right. We dived a little deep about what are factors, right? What are factors? We we did study some prime factors, the concept of prime factors, right? um, and how did we come up with this name, like prime factors? What exactly are prime factors? So factors which are made up of prime numbers are called prime factors. That's what we studied, right? um, so I guess this is it. I do not recall much from what we did last time. All right. So this is what I think we did. All right. So we're going to continue off from where we left. We studied a concept called LCM, and it was essentially used to find out all the multiples that can be used in order to find out the numbers that can make up that number. All right. So the multiples that combine together in order to make up that number are called multiples. Let's say if I have a number 10. All right. So how many numbers can combine together, that means multiply together, to form 10? Right. So I taught you guys a way which was to draw lines like this. All right. And start using, like, dividing it with the least number that you know. All right. So what's the least number that you know which 10 is divisible by? So I guess it's 2, right? So let's divide it with 2. What are we left with? We're left with 5, right? And so we divide 5 by 5 because there's no other number which can divide 5 except for 5. All right. So we're left with 1. So this 1 indicates that we stop now. All right. So these two can be referred as multiples. All right. These two can be rated as factors that form 10. All right. These two can be rated as factors individually, like 2 is a factor. 2 is a factor, right? And 5 is a factor, right? 5 itself is a factor, because both of these numbers can be used to divide 10. If we divide 10 individually by 5, we do get a value, right? So hence 5 is a factor. So any number which can be divided by the other number and we get an integer in response, that means it's a factor. All right. So I hope this is clear. And now what are multiples? Multiples are basically, this is a multiple, right? And now the basic concept of multiple comes in when we have more than one number over here, right? So now, right now we were just thinking of one. Now if I give you a question to find out the multiples, to find out LCM, like least common multiple. LCM stands for least common multiple of 10 and 36. All right. 10 and 36. So what are we going to do? We're going to take both of these numbers. And start dividing them. All right. So if we're going to take one number which can be used to divide both of these numbers. All right. So what's that one number which can be used to divide both of these numbers? There's 2, right? So if I divide it with 2, I'm gonna left with 5 over here, and 36 divided by 2 is 18, I guess, right? Yeah, 36 divided by 2 is 13. All right, so now what do we do? As we're left with these two numbers, now we're gonna come up with a single number. Ideally, we should come up with a single number which can be used to divide both of these numbers. So in my knowledge, there doesn't exist a single number which can be used, because here it's a prime number. 5 is a prime number, so no other number can be used except for 5, right? And here it is 18, so 18 can't be divided by 5. So what are we going to do? We are going to take 5 first. Let's take 5 first, right? So we're done with 5, right? 5 divided by 5 is 5. So 18 can't be divided with 5. So what do? We just take 18 as it is. Okay, right? Now what do? We form up a method to divide 18 further. All right, so we take 2, divide it with 2. 1 does not have any effect on it, and now 18 is gonna divide by 2, it gives us 9. All right, now we're gonna divide, we're gonna use 3, and it's gonna give us 9 divided by 3, left us with 3. Now we're gonna use 3 again. All right, so we're gonna left with 1. So until we reach 1 on both the conclusion, we're gonna keep dividing our relative terms. All right, so this, what we get, is called the least common multiple. All right, so least common multiple is basically a number when which comes in both of these tables. All right, let's check. So what do we say? It's gonna be 2 times 5 times 2 times 3 times 3. All right, so let's organize it a bit. So it's going to be 2 times 2 times 3 times 3 times 5. Now these two numbers are repeating, so we can write it down as 2 squares multiplied by 3 squares multiplied by 5. So if we do it in the calculator, what answer do we get? All right, so we're getting 180. All right, so 180 is gonna be the number. 180 is gonna be a common number which can come in either one of these tables. All right, so if we divide 180 by 36, let's see if we get an answer. So 180 divide by 36, what do we get? We get 5, right? So it can be divided by 36. Similarly, if we divide 180 by 10, we get 18, right? So in either cases, we're gonna get the answers, right? So this is our answer for least common multiple. So the first number which comes uh, when we talk about both 10 and 36 being divisible by that number. All right, there might be multiple other numbers, right? But the smallest, the first number that comes in mind is 180. So do you guys have any questions? Or if I think, yeah, Mr. Beast, you've answered it right. 180 is the answer. So do you guys get the concept of what do I mean by least common multiple? Is there any question? If there's anything that you guys did not understand, feel free to ask me, and I'll be more than happy to help you out. All right, so I don't see any question as of yet. So let's move ahead. All right, now what we're gonna talk about is HCF. Perfect. Now what we're going to talk about is HCF. Okay, so what's HCF? Now remember, I'm it's not like just random things. I'm just deliberately deriving it from factors, right? So it has to do something with factors. Can any one of you guess what HCF is, and or maybe what does it stand for? HCS, HCF, yeah, highest common factor. Exactly, accurate. So it stands for highest common factor, right? So this is basically not that advanced of a topic, so I'm just going to go through um, I'm just going to go through this topic really quickly because it utilizes essentially the same concept as LCM. So let me give you, I'm going to explain this topic with the use of a past paper. All right, so what are we going to do? This is the question that was in the exam. Okay, so yeah, so this is not some question which I gave. This is the past paper question. All right, so it essentially means that we need to find out the factors of the following: 36 HCF of the following: 36, 54, and 60. So does that mean that we have to do it together? Yes, it does. All right, so we have to find out a single factor which can be divided with all of these numbers. All right, so how are we going to do that? There's a very easy step to do this. Okay, so what are we going to do? um, there are basically two ways to do this, so I'm going to teach you both really quickly. All right, so first we do it in the way we did LCM. So we're going to write all of these down: 54 and then 60, right? This might become hectic sometime, but trust me, it's gonna, in the long term, it's gonna be, if you practice it well, it's gonna be really easy for you. So 36, 54, and then 60, right? So now we need to find the smallest number which can be used to divide all of these. All right, so we take 2, right? 2 can be used to divide 36, 54, and 60 as well. So first 36 we get 18, right? What do we get when we divide 54 by, what do we get when we divide 54 by 2? So we get 26 or 27, 27 I think. Yeah. um Now if we use 2 to divide with 60, we get 30, right? So now we've reached this number where we have 18, 27, and 30, right? So which is one number that can be used to divide all of these numbers? And it, mind you, it should be the smallest number possible. All right, so let's start with 2. Can 2 be used to divide all of these numbers? Yes, 2 can be used to divide 18, but it can't be used to divide uh, 27, right? So we can't use 2 here. Now let's try with 3. All right, if I take 3, 18 divided by 3 gives us 6. 27 divided by 3 gives us 9. All right, and now 30 divided by 3 gives us 10. So 3 can be used. Now if I come across this, can I use a single number which can be used to divide all of them? Can I use 2? I cannot, because here's 9. Can I use 3? I cannot, because here's 10, right? Can I use I can't use 4. I can only use like the prime numbers. All right, so I can not use any odd numbers, right? Now let's go with even numbers. Can I use 5? I cannot use 5 because of 6 and 9. Can I use 7? I cannot use 7 either. And because it has already crossed the smallest number, which is 6, so there's never going to be any number which can be used. So here is the time when we stop. Okay, so these two, when we combine them together, when we multiply them together, 2 into 3, we get 6. So 6 is the answer that we're looking for. 6 is the only number, highest common factor. So 6 is the only highest factor which can be used to divide all of three numbers. All right, do you understand this? If there's any other question, then we can use another alternate method. I have an easier alternate method for you guys. So if you do not, I personally believe this method is far more easy. But if you don't understand this, we can always go for another option. So, is there anybody amongst you that who find it really difficult here, or do you guys get the concept of HCF? HCF. I am not getting. Right, so I'm not getting any questions. That means you guys, all of you guys, understand this. Perfect. All right. So, with that being said, let's move ahead to the other topic. All right. Now, what we're gonna do, we're gonna talk about something called places. All right. So now we're gonna learn a little bit about um, places. So what do I mean by places and like place? What do I mean by places? It basically means the number, uh, like the place values. All right. So what do we call them and how do we indicate them? Because that's very important when we're gonna go about into topics which are related with um, let's say which are related with ordering them or maybe rounding them off, right? So that's when it matters a lot. So let's say that we have a number line of this color. All right, so now let's mark this point as 0. All right, now this point I explained it earlier, that's going to go into positive infinity. Why am I writing positive infinity? Because the number can go to the largest point possible. All right, there's not going to be any number which is not possible. You can imagine any highest possible positive number and it's going to be there, right? By writing this, I mean that. Okay, similarly on the left hand side we write negative infinity. That means it's going to go on to the maximum possible negative number that you can imagine. It's going to be there in the number line. All right, so when I say that, I talk about, let's place 1 here. All right, now if I write it as it is, so let's imagine a number. All right, let's imagine 10304. All right, so this place is called units. What is it called? Units. All right, units. All right, this place is called tens. Right, now this place is called hundreds. Obviously, I hope you all know this. I'm just reminding you of because I'm going to go into after the decimal as well. And this place is called thousands, right? And then this place is going to be called ten thousands, right? Ten thousands, right? Now, let's imagine me writing a number which is exactly this 10304, I think, but 0.234. Right, so what is it that I'm talking about? Right, so this place is called 10th. This place is called 100th. All right, so 10th, 100th. It's not called 100, it's called 100th. Right, then this place is called thousandth, right? And then this, let's write 6 away, and then this is 10,000th. Just write th at the end, and it's going to be that. Okay, so do you guys understand this? I have a chart as well, so let me just copy this image and try to paste it here. All right, so here's the chart, right? So this number was 23.31, and then 3 is the 10th position, and this is 100th, 1000th, and then 10,000, right? So this is what essentially covers your part of the syllabus. And now we're going to move on to the topic which I told you was going to be associated with this. It's called rounding off, right? So what is it called? It's called rounding off, right? So what do I mean by that? What do I mean by rounding it off? So it essentially means that if I'm given a number and I have to round it off to a certain decimal places, so these are called decimal places, right? After the mark, after the dot decimal, this is the first decimal place, second decimal place, third decimal place, fourth decimal place, and so on, right? So if I write um, a decimal value in front of you, 23.375, right? And I'm telling you to round it off to the nearest hundredth. The question is to round it off to the nearest hundredth. All right. So what exactly are you gonna do? Does any one of you have any idea how to solve this? The question is to round it off to the nearest hundred. So what are you gonna do? Perfect. Thanks for joining in. And now, so does any one of you know how to talk about, how to round a figure off? How do I solve this? What do I do? Just give me a hint, like what do I do in this question? All right. So just to show it off, just to guide you guys a bit, what I'm gonna do, I'm gonna show you how to do this. All right. So this is our number, right? Yeah. So this is essentially what our number represents. Now we're gonna go to the hundredth position. So which one is the hundredth position? Which one is the hundredth position? So this is 10th, right? 10th, and then this is hundredth, right? So we're gonna take it, we're gonna mark it. Okay, like I've marked it, we're gonna mark it. All right. Now what we're gonna do, we're gonna see. Okay, so what we're gonna do, we're gonna see the next number to it. Okay, so what's the next number? The next number is 5. If the next number to the number that you originally marked is greater than 5, you're going to add 1 to the existing number. So as greater than or equals to. If it is greater than or equals to 5, we're going to add this, we are going to add 1 to the existing number. So the final answer would be 23.38. So this is what we say when we this is what we mean when we say to the nearest hundredth, right? It's going to be 23.38. All right, so this is going to be the answer. If let's say our question was a bit different, if our question was 23.372, right? Now we're gonna mark the 100 position and we're gonna see back. Now this number is lesser than 5, right? As this number was greater than or equals to 5, this number is lesser than 5. So what do? We drop off all of this behind and we're gonna write 23.37, and that's gonna be the answer. Is there anybody who doesn't understand this? Now we're gonna do, don't worry about it, we're gonna do a couple of questions. Okay, so we're gonna do a couple of questions now. Let's say that we have 39.1297, right? Now we have to first round it off. In the first part, round off to the nearest tenth. In the second part, round off to the nearest hundredth, right? And then in the third part, round off to the nearest thousandth, right? So these are the three questions that we have. I'm sure everybody can see the screens, right? It's visible to everyone. All right, so what do we do for the first part? What do we do? All right, so one of you have already given me the answer, right? So I guess Locius, I guess you're right. So what do? We take this number, all right? So we take this number 39.1297, all right? So the place where we have to mark the tenth, right? Round it up to the nearest tenth. So we're gonna take this and we're gonna look back. So by looking back, we see that it's 2, so it's less than 5, right? So what did I tell you? To drop everything else. We're gonna left with 39.1, right? So this is the correct answer for the first part, right? Now coming on to the second part. All right, so coming on to the second part, what we're gonna do, we have 39.1297. We're gonna have to mark the 100th position. So the 100th position is this. We're gonna look back. If the next number is greater than or equals to 9, what do? We add 1, right? So our answer would become 39.13. Is this clear? Do you guys have any questions? Feel free to ask me. So the ones that asked me to do the second one, do they get it now? Is it clear? How are you solving question number 2? Right. So let's move ahead and start off with the question number 3, right? So now we're gonna round it off to the nearest thousandth, right? So what do? We write down the question 39.1297. So just take a minute, and it would be great if you guys could find the answer yourself and comment that into the chat. Okay, so comment the correct answer into the chat, and the one that got right, I'll announce his name as well. So just write it down in the chat. Let's come on, just quickly. It's your chance. 39.120. No, I don't think that's the correct answer. You are on the right track, but you've missed out one digit. It's not going to be 20. All right, so let's try this question now. So what are we going to do? We're going to point out the value of the hundreds. So that's 9, right? We look one back. So it's 7. So it's as it is greater than and equals to 5 or equals to 5, we're going to add 1 to 9. All right, so adding 1 to 9, it becomes 10, right? But this place can only hold 0, and 1's going to carry forward, so it's going to be 30, right? So the final answer would be 39.130. Just imagine that you're adding 0.129 and you're going to add 0.001. So what do? We have to add 0.001. So what do? It becomes 0. We're going to add carry it away. It's going to be 3, and then it's going to be 1, right? So this is how we've reached out to the conclusion. I've got one answer, which is 39.13, but as I've written it to round it off to the nearest thousandth, we have to write 0 afterwards. 39.13 is correct, but it's not right to write it down as 39.13. When we've asked you to round it off to 1000, that means 0 is going to be added there, right? So just to clarify. All right. So is there any question that's left that you think you might wanted to ask and it hasn't been answered? All right. So let's move ahead. Perfect. So let's move ahead, and we're gonna go on to the topic, which is um, right. So let's talk about prime numbers for a bit. All right. So we're gonna make up the list of prime factors. Um, in the last class, I asked you a couple. We did go through this topic, I think, but let's do it for the ones that have just joined us. All right. So prime numbers. What are prime numbers? What are prime numbers? quickly. We did this in the last class. So does anyone know what are prime numbers? Well, its prime numbers are essentially the numbers that only come can only be divided by itself. That's partly true, right? That is the correct definition. However, with a little addition of the numbers that can only be divided by itself and one, right? So I know most of you don't count one as a dividend, but it is used in most of the cases, and it would be one of the primary factors as well. So numbers that can only be divided by itself and one. All right. So just a little bit addition to what's been answered. Um, okay. So can you guys give me in GCSEs? One of the most major thing that you can be asked of is to identify prime numbers between 1 till 100. All right, so you guys, what you guys need to do is you guys need to make up a list, and one's not going to be included. Okay, so one's not going to be included in the list of prime numbers because one can be, one can come in any table, right? So one doesn't need to be there, but you guys need to make up a list of all the numbers that are prime in the collection of 1 till 100. All right, so what they can ask you is they can ask you for major sets and different connections between them, right? So just to start off with a few, I'm gonna do till 10, or maybe till 20. Okay, so I'm gonna do till 20, right? So just to name a few, 2 is a prime number, 3 is a prime number. Is 4 a prime number? Is 4 a prime number? Because if we write 4, can 4 be divided by any other number than other than 4? Of course, it can be divided by 2, right? So the answer is 2. So if 4 is divided by 2, then it's not a prime number. Then it's not a prime number, right? Now, if I go on to 5, 5 is a prime number, um, right? And then 6 is a prime number. 6 can be divided by 2, 6 can be divided by 3, so it is not a prime number, right? We can count 7 as a prime number. Can we count 8, 9, 10 as a prime number? All of these can be divided by either 2 or 3, so they can't be a prime number. 11, however, is a prime number. 13 is a prime number. Similarly, 17 is a prime number, right? So all of these and 19, obviously 19 is a prime number as well. So all of these numbers are prime numbers till 20, right? Till 20. Now similarly, you guys need to make a list for all the numbers that are prime in 1 to 100. Am I clear? This is only for you. You don't need to submit it anywhere. This is just gonna be helpful when you are giving your GCSE exams. All right, so moving ahead, now we are gonna go over the topic of power and roots. Right, this is something that it's all right. So what do I mean by this power and root? What's power and what's root? Now we're gonna talk about something called power and root. right? So let's write them down separately. So what's power? When I say power, what do I mean by that? All right. So any number, let's say that you have a number, let's say 4, right? So this is called base, and if it has nothing over the top, it means that it has 1 as a power. So anything that has a power of 1, any number that has a power of 1, the answer would be that number only, right? So if I just write down a random number like 13, it it means it should be understood that it has a power of 1. All right. If I write down a number like 4, it should be understood that it has a power of 1. Okay. If I say a number has a power of 2, what do I mean by that? Instead of 1, now it's 2. What do I mean by that? What I mean by that is that 4, the base number, is going to multiply with itself exactly the number of times that is written here. So it's 2, right? So the base number is going to be multiplied with itself by 2. So 4 times 2, 4 times 4, right? So the answer would be 16, right? If I say that 4, it's 4 cube, it's not called 4 to the power 3. It can be called 4 to the power 3. There's no harm in it, but we usually prefer to call it as 4 square. It's called 4 square. In words, it's called 4 square. Okay, now it's called 4 cube. So what's 4 cube? What's 4 cube? What are we gonna do? We're gonna multiply 4 by itself 3 times, right? So 4 multiplied by 4 multiplied by 4. So the answer would be what? 4 times 4, 16 times 4, that makes up 64, right? So it becomes 64, right? And we can continue to go on with 4 times 4 to the power 4. That means we're going to multiply 4 with each other for 4 times, right? So 4 times 4 times 4 times 4. So it's going to become what? It's going to become 256, right? Am I Do you guys understand this? Now there are certain basic power rules. Okay, one of the power rules is this, which I've just taught you. Okay, it means that any variable, let's say, like, let's take a variable x. So any variable that has a power of 1, it becomes that only. All right. So if I say, the other rule is that if there's any variable means that if there's any base, right, it has a power of 0, what does it become? So it's an open question. You guys, all of you can answer it. Okay, let's engage in the class. So what do you mean by when I say that any number that has a power of 0? For example, I say that 2 to the power 0. What's going to be the answer? If I say that it's going to be 2 to the power 0, it's going to be the answer 1. Okay, so Akhil has answered it right, so it's going to be 1. So any number that has a power 0, it's going to be 1. No matter what the base is. The base could be 10,000 even. If it has a whole power of 0, it's going to be 1. Am I clear? Is So these are the two golden rules that you need to know. All right. Now let's come on to the other part of this, which is roots. So what's root? All right. So what's root? Root basically indicates the opposite of it, right? I told you how to find out the roots, right? The other day I told you find out the roots, how to find out the roots. So if I say that a root is basically what, um, you have to find out if there are different type of roots. So if it's the general, the general form of root is written like this, okay, with this indicator. Okay, so if I say it's a root of 4, that means what I need to do, I need to take out the LCM for 4. So let's take out the LCM for 4. It's going to be 2, it's going to be 2, it's 2 again, and it's going to be 1, right? So I write down these two multiple, these two factors of 4 under the root, right? And I'm gonna take out one of them. I'm gonna form pairs. Why am I forming pairs? Because root essentially means that it's a root of 2. Okay, so whatever the number is here, I'm gonna form that many pairs, and if there's nothing written here, that means it's standard that it's 2. Okay, it should be understand that it's 2. If there's nothing written here, it should be understand that it's 2. All right, so I'm gonna form pair of 2, and I'm gonna take one out. So I'm writing one out. I'm gonna take one out like this. Okay, so I'm gonna take one out, and what's gonna be left? There's nothing gonna be left. There's just one, right? So rule number one for root says if root of 1 is always gonna be 1. So the root of 1 is always gonna be 1. So it 2 times root 1, that means it's 2 times 1, and the final answer would be 2. All right? Do you guys understand this? Right? Now let's talk about a couple of more roots. If I say that's not square root, right? It's maybe cube root. It's called square root. This thing is called square root. Square root. All right. Now, if I say that's not square root, it's going to be called cube root. So, if I have to find out the cube root of 64, what do I do? It follows the same procedure. I'm going to have to, take out the take the cube root, take the LCM of 64. So I'm going to divide it with 2. I'm going to be left with 32. I'm going to further divide it, and I'm going to be left with 16. And then further dividing it, I'm going to get 8. And then further dividing it, I'm going to get 4. And then 2 again. And then 2 again. So I get how many twos? 1, 2, 3, 4, 5, 6 twos. Right? So I'm going to write them all down. All right. So these are 6 twos. Now, how many pairs I'm gonna form? I'm gonna form how many pairs? Now it's a cube root, right? So I'm gonna form pair of threes. Okay, I'm gonna form pair of threes. So 1, 2, 3, one pair. 1, 2, 3, second pair. So I'm gonna take one out from each pair. Okay, so one from this pair, one from this pair. What am I gonna left with? One, right? So as I told you, under root of 1 is 1. So the final answer would be 4. Do you guys understand this? Is it clear? If there's anything that's not clear over here, please do tell me. Right, so if I continue and I want to find out now, if I write my answer as maybe 6 squared, okay, and now if I apply square root over it, so it's a direct procedure. I can cut I can cut the power with the root, but it has to be the same root. I cannot cut 6 cube with under root of like I cannot cut square of 6 with a cube root of 6. I cannot cut these. I cannot do this. Okay, the power, if the power is 2, then it has to be the square root. Okay, if the power, I can cut, obviously if it's 6 cube, then I can cut the cube root with it. Okay, both root and the power has to be same in order to be cut. If I do this, then the answer would directly be 6. Okay, if somebody asks you what's the cube root of 6 cube, so you can just cut the root and cube together and the answer would be 6. Do you understand this? So this is a shortcut. This is a shortcut. This is a shortcut in order to find out the roots. All right, so now before ending, I'm gonna just give you guys a quick question. Now I have to find out the cube root of 125. Now let's see who gets the answer quickly. All right, I'm waiting for your answer, guys. Hurry up, write it in the chat, and I'll read out the one who got the exact correct answer. What's the cube root of 125? Come on, quickly. Cube root. It's cube root of 125. So the first person who has answered it correctly is Akhil, and he has answered it right. So it's 5. How is it 5 now? Now let's. Okay, so another person has answered this right. Okay, so how is this 125? Okay, so what are we gonna do? We're gonna find out the number which can be used to divide it. Can 2 be used in order to divide 125? No, 2 can't be used to divide. Okay, so we use 5 instead. So what are we left with? 25, right? Now we're gonna further divide it with 5. So we're gonna left with 5. Now we're further dividing with 5. We're left with 1. So this is where we stop. So we just have to write down 5 into 5 into 5 and the cube root. Now we're gonna form up the pair of 3 pairs of 5. Okay, so we're gonna take one out. It's the answer would be 5 root 1 and the answer would be 5. So Akil was right. He was the first person to answer this correctly. Good job, well done. All right, so now I have another question. All right, now I need an answer of 54, square root of 54, right? And I do not want numbers. I do not want decimal places, so do not use calculators in order to find out um, the answer. Yeah, correct. Good job. Good job, everyone. I see a lot of answers here. And now I want a square root of 54. Perfect. Good job. I see a lot of answers to the previous question. Great job. I'm happy that you all are doing it right. So 54, what's the square root of 54? Okay, so I do not specifically want 7.3. I got an answer 7.3, which is correct, but I do not want it in decimals, right? The answer is absolutely right, but I do not want it in decimals, because in this type of exams, this type of questions mostly come in P1, which is without calculator, so you're not allowed to use calculator in there. So what we are going to use is we're going to divide it with 2, so we're going to left with 27. Now we're going to divide it with 3, so we're left with what? We're left with 9, right? We're going to further divide it with 3, we're going to left with 3, we're going to divide it with 3, we're going to left with 1. Okay, so just write all the factors down: 2 into 3 into 3 into 3. Okay, so we need pair of the same number. So this is there's no other 2, so we can't take 2 out of it, right? And there are only three threes. Okay, so we have to form one pair and take one out. Okay, so if we take one out, if we're gonna take one out, we're gonna be left with what? If we take one out, right, we're gonna take 3 out, and then in the square root we're gonna be left with 2 times 3, so it forms 3 root 6. So this is essentially what I was looking for, and this is where you're gonna leave your answers in the exam as well. Without calculator, this is where you're gonna leave your answers, and it would be marked correct. Do all of you understand this? Is there any question, anything that you did not understand from today's lecture? Feel free to ask me. We have a couple of minutes, and this is open floor. You guys can ask me anything from what I've taught till now. Feel free to ask me anything that you want to. All right. So, is there any questions from today's lecture? Somebody answered it as 3 root 2, where the answer would be 3 root 6. Why 6? Because we're left with one other 3 and one 2. So it's going to be 3. Yeah, you've corrected it. So great. I do not see any questions as of yet. So whatever is taught to you today is fully understand, I believe. I'm believing that. One more example of the last question. Okay, so let's do that quickly. Okay, so if we have, let's say if we have 60 or maybe 70. Okay, let's say 70. So what are we gonna do? We're gonna divide 70 with 2. Okay, so we get 35, right? um no, we can't use 70 over here, we have to use 60. Let's take 60. Okay, let's take 60. So we divide it with 2, we're left with 30, right? Now if we're going to further divide with 2, we're left with 15. Now we can use 5, we get with 3. Now we're going to use 3, we're left with 1. Okay, so let's write down all of these: 2 times 2 times 5 times 3. Okay, so we form a pair because it's a square root, so we form a pair of 2. We take it out, we take it out, The rest of it stays under the root, so it's 5 times 3. So the final answer would be 2 root 15. Okay, so I hope this was clear. If there's any question, feel free to ask me. I'm hopefully gonna see you on Monday. Till then, hopefully take care of yourselves and have a great weekend. All right, so this is it. I hope everything's clear. Take care, everyone. Enjoy. Goodbye.